Okay, so today it's June the 7th, 2012 at 10:04 a.m. And this is part 226, line 19, A5 Quadratic Anisotropic Rocket Motor Noether's Theorem Wow Seti. Now there's the alien radio signal equation with the answers. I googled both of them to find out what comes up. So this is the first thing that came up, was parallel simulation of multi-component systems. It's a PDF file from MT Heath. It says modules solve the integral form of the 3D time-dependent compressible Euler or Navier-Stokes or quadratic 10-node tetrahedral elements or complex geometries with anisotropic geometries, the case of a rocket motor. So that came up. So then I googled the keywords quadratic anisotropic rocket motor, and of course I was working on this May 29, 2012. 9:25 p.m. is when I started doing the research. I actually started working on this lens May 14th. These files come up. A variational principle for an incompressible and nearly incompressible anisotropic elasticity. Samuel W. Key from New Mexico, and the abstract says a specialized form of Resner's variational principle is developed which is suitable for anisotropic, incompressible and nearly incompressible thermal elasticity. The finite element method is used to find solutions in two axisymmetric problems where the material is cylindrically orthotropic and incompressible. The developed variational principle has the feature that the volumetric strain appears in only one equation, and errors committed in approximating this equation do not re-enter the stress calculations. And of course it comes up in Russia. So is the United States Atomic Energy Commission. So this is investigation of the stability of metallic composite. For some reason it's not. There we go. You can see it better. It's another PDF file from H.P. Lee. It's solid rocket motors consist of a thin metallic or composite shell filled with a soft rubbery anisotropic composite thin and high strength shells, which are the main space. Quadratic elements are chosen to mesh a half ring model. Okay, so that's one came up there. So I'm going to Google the keyword axis symmetric, and wiki quotes is an object with rotational symmetry is an object that looks the same after a certain amount of rotation. Noether's theorem has become a fundamental tool of modern theoretical physics and the calculus of variations. A generalization of the seminal formulations on constants of motion in Lagrangian and Hamiltonian mechanics developed in 1788 and 1833. Respectively. It does not apply to systems that cannot be modeled with a Lagrangian alone, e.g. systems with a Rayleigh dissipation function. In particular, dissipative systems with continuous symmetries need not have a corresponding conservation law. So here's the graphics that I found. Angular momentum in terms of scalar and vector components. That's what it looks like. And the next thing that came up was this one here. Our orbital spin talks about orbital quote wiki conservation of angular momentum distributed between the spin and orbital angular momenta. The moment of inertia and angular velocity of the spinning body are about its own spin axis, and its position is radial from the orbital axis and momentum tangential to the curve. Here circular orbits are shown. Similar illustrations would follow for an elliptical orbit. Okay, that's the end of that video.